Today's lesson is on Chapter 7, Section 2, Solving Systems Using Substitution. So we're still trying to solve a system, meaning just like with the graphs, we're trying to figure out what ordered pair will work for both equations. But instead of graphing it now, we're using what's called substitution. So you still have these two equations. You could easily graph both of them and figure out where they intersect, but that's not how we're going to solve this. We're going to solve this a totally different way. So we have y equals negative 4x plus 8 and y equals x plus 7. I'm going to use this equation. This will be my standard equation. I just chose one of them. It doesn't matter. And I'm going to substitute in the other equation. So ignore this equation for now because that's the one we're using down here. In the second equation, it tells me that y is equal to x plus 7. That literally means that I can substitute in x plus 7 in place of y because that's what y is equal to. So what I did here was instead of putting y, I substituted x plus 7 in place of y. Now that I know that this is my new equation, I can solve it because I have the same variable, x and x. Okay, so what I'll do is I take that equation, I put the 5 steps down here. Let's separate our two sides and use the distributive property, which we cannot do because there's no parentheses. Combine like terms. On the left, I've got a letter and a number on the right, so skip it. What we need to do is gather variables to one side. I chose to move the x. Since it's positive, I'll subtract x from both sides. That way, the x's cancel, bring down the 7. Negative 4x minus x is negative 5x, and bring down the 8. Now we need to undo addition or subtraction, so I subtracted 8 on both sides, and we get negative 1 equals negative 5x. Last, undo multiplication or division, so divide by negative 5 on both sides, and you can leave it as a fraction. I chose to change it to a decimal, which is 0.2. Now we're not done yet though. When you get to this point, remember our goal is to get an ordered pair. Well, we have 0.2 for x, but we still don't know what y is. So what we do now is we know that x is 0.2. I can use either equation. These are the two equations that I was given in the original problem, and I can use either one of them. Well, to me, this one looks a lot easier because there's no multiplication. It's just adding. So I'm going to plug in 0.2 in place of x. What I did right here, okay? So now y is equal to 0.2 plus 7, which is just 7.2. So my ordered pair is 0.2, 7.2. This is the ordered pair at which those two equations will intersect on a graph. Notice they told me to use substitution because if I were to graph this, it would be nearly impossible to get this exact answer. So it's easier to use algebra in some cases and solve it than it is to actually graph it. All right, one more example. Again, solve using substitution. Look at our two equations here. What you have to have is one of the variables needs to be by itself. In the last one, it said that y equals blah, 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 blah. Here, we don't have any variable by itself. So what I decided is to take this second equation and get y by itself. That would be the easiest variable to get by itself because it doesn't have a coefficient. Well, it does, but it's 1, so I don't have to divide. This y has a 3, this x has a 2, this x has a negative 6. This y is all by itself already, so it'll be easier to get alone. So I have this equation. I'll separate my two sides, and in order to get y by itself, since this is a negative 6x, I need to add 6x to both sides. That way the negative 6x plus 6x cancels. I brought down the y, and I cannot add this, so I just literally write it negative 7 plus 6x. Now I know that y is equal to this. So that's this equation and it's done. So now I'm taking this quantity and plugging it in place of y in the other equation. So here's my other equation. Okay, I just rewrote it down here. And in place of this y, I'm putting this quantity right here. I have to put it in parentheses though so that I can see that I'm multiplying by 3. So I took the 3. In place of y, I put this entire quantity, -7 plus 6x plus 2x equals 4. Everything else stayed the same. All I did was in place of y, I plugged in that quantity. Now it's just a matter of solving that equation because we have the same variable. So step 1, use distributive property. So I did 3 times -7 is -21, and 3 times 6x is 18x. Then combine your like terms. Now we do have like terms because I've got a positive 18x and a positive 2x, which can combine to positive 20x right here. And now we need to undo addition or subtraction, so I'll add 21 on both sides. And that way we get 20x equals 25. And then divide by 20 to get x by itself. And we get x equals 1.25. Again, we're not done yet because I know x is 1.25, but I still need my value for y. Again, it doesn't matter which equation you choose. Go back to your two original equations. I chose the second one, -6x plus y equals -7. And I just plugged in 1.25 in place of x. Everything else stayed the same. So now I'll separate my two sides and multiply -6 times 1.25 is -7.5. And then to get y by itself, I need to add 7.5 to both sides, and we get y equals 0.5. So our ordered pair is 1.25, 0.5. That's where these two lines will intersect on a graph. And that's all for solving equations using substitution. Bye-bye.